Cool. So yeah, there wasn't anything super specific. Obviously, we've got a bunch of open questions still, and yeah, maybe if you haven't seen, made some really nice updates to the document, just kind of cleaning up some of the written notes and also kind of making the diagrams uh, not kind of handwritten and stuff like that. Um, and then we had the kind of neuroscience questions. There was like 4 or 5 from last week. There was some discussion on the group. I don't know if anyone's kind of done any reading beyond what was kind of discussed on there. But yeah, so we can kind of approach any of these we want. And then one thing we're talking, it might just be useful to kind of review the sort of existing model of how we think behavior might be working, just to kind of clarify any uncertainties that might be there. Um, but yeah, maybe on the kind of neuroscience one, or yeah, what were you going to say, Viv?
Oh yeah, I was just gonna say, yeah, I think on Rami's write-up we had a couple of comments about how the two models can be learned independently and applied independently. So yeah, just in the kind of recap of what we currently have as a framework, I think we were talking through that again to make sure everyone is on the same page, because that's like one of the two key ideas, I feel like. So just want to make sure everyone understands that part.
Yeah, that would be
Right.
great. I feel a little lost. And
Yeah, no, no
yeah.
worries. I mean, it's complicated. So, oh yeah, and then also Jeff has been working on writing up like a version of this to be published, so we can start publishing these research meetings in more for like patent disclosure style. That's where I took these diagrams from. But yeah, we can hopefully share that this week.
Nice.
Um, but yeah, I mean, I can talk through the current state, but maybe it's actually better if, well, for one, because of my voice, but also because it might be good for one of you to kind of test your understanding if someone else tries to explain it or tries to explain how they think we think about it.
I can try.
Sure.
Uh,
Yeah, nice.
should I try and share my screen? Where's the document? Let me see.
Yeah, I feel like yeah, those uh figures might find helpful. It should be. We can share again.
Linked in the research meetings channel, I think.
Yep. Hmm. Can you see this?
Yes, yeah.
Okay. So in the cortical column, we have a layer 6A where there's the reference frames, and these are um, path integrable, and it's basically just a physical location with respect to the object. So it's in the reference, it's allocentric reference frame with respect to the object. So any movement of the eye or movement of the sensor is going to be transformed into, and it will be used to change the location in this reference frame. But there are other movements like a change, like a local movement change that is in the basically a visual stimulus move or like an object changing, and that will be going into a layer 3. So basically there are a lot of parallels between the morphology and the behavior model, but so in summary, it will be just basically there's two reference frames, one for the behavior and one for the location, and one for the model, the morphology model, and then they will be moving in synchrony. But also the behavior one will be associatively linked to changes of the object, so or some movement of the object, and the morphology model will be associatively linked to features like colors and or orientations or edges and stuff like that.
Everything you're saying is correct. I'm just where you're pointing just to make
Oh,
the purple ones are the behavior model errors, and the green
all right.
ones are for the morphology one. And I wrote object model instead of morphology model, but we kind of use those terms interchangeably right now.
Okay.
But yeah, go on.
So the associative connections between the two layers, between the movement, between the location, and whether it's the static features or the changing features, the movement features, that's what determines whether this is a morphology model or if it's a behavior model. And it's just in a similar way to how we pull features at locations into object IDs, would be pulling movement at locations into behavior ID. And then these would be going to the higher level, or that's we could discuss that after. The time here that's coming from, we think it's coming from matrix cells, and it's just encoding the intervals between every time we receive a change, it's basically just encoding how long between these changes it takes. So just like kind of like a tempo thing, but anything that works for both feature change and the static features.
The temporal part doesn't go into the morphology model, so at least not in how we talked about it so far. So that's what this neuron that sends up its apical dendrites to L1. That one only is in the behavioral model. So only for the behavioral model do we have like a temporal sequence of changes. And then for the static one, since it's static, there's nothing that changes over time. So we don't have a connection to layer one.
So as we observe the object, the movement of the eye, yeah, I think it doesn't matter. Okay, so the intervals between when we get these static features doesn't really matter at this point.
No, because the eye movement is already integrated in layer 6A.
Okay.
And like how we move over the object and in what sequence doesn't matter at all for recognizing the object. So we don't need to learn a temporal sequence there.
Okay. So in the sense, a melody would be a behavior then.
Yes.
Okay.
Jeff is in the document. Should we like ask, since he's looking at the same document, if he wants to join the Zoom as well?
Just write in red big letters.
Hi, Jeff. You are in Zoom. I don't know if we can see it or not.
Okay. So this is the part I understand, even though I've described it very differently in my write-up, because I was trying to propose a different thing. But I'm interested in, so now I understand that these movements are in physical 3D space. So basically what we're learning as changes at locations, these locations actually they describe the relative locations between, they basically describe relative locations in physical 3D space. So if we're modeling changes there, it will be tied to whatever morphology is defined by the relative locations. This is the part where I'm getting confused. So how is it?
The morphology model, like I think that maybe that's a bit of the terminology confusion. I guess when we say that this green one defines morphology, it's in the sense that it stores like the point normals and curvature directions and curvature, like all these static features at those locations that define the morphology of the object. But just like only the locations themselves aren't like part of the morphology model, if that makes sense. Like just movements relative to each other in space that are encoded in the behavior model, they don't represent anything about the morphology of the object. They just represent which parts move at what points in time in which directions, or which points change their features, but not the features that are there themselves. Does that make sense?
Yeah, okay. Yeah, it makes sense, but there's still relative locations. So sure, for the morphology model, we're storing edges at these relative locations, and that's how we understand the full model. But when we're dealing with a behavior model, we're storing the movements also at relative locations. So in some sense, these relative locations would not be the same if you're talking about a different model. Does that make like so for
Well,
example,
I guess it ties in. I think we talked about that, like in some sense, the how you apply behavior to an object depends to a certain degree on its morphology. Like if there's no way to map those two, then it's not clear that you can map that behavior onto it. So as in like
Like,
take
I mean,
like
yeah, if you
a
have,
ball, like a sphere can have the hinge behavior, but that happens by mapping like parts of a ball that kind of approximately look like a hinge and like splitting it in half. If
right?
you took the top curve of the ball and the bottom curve of the ball and they were kind of doing like that, that's not really like hinge, or like that's something kind of different, I guess in some sense. So yeah, so I feel like there is an implicit morphological kind of model there, but that's kind of part, I guess, of how the behavior maps onto it.
Yeah,
yeah, I
and
mean, I
I mean, go ahead, sorry.
um, yeah, several thoughts, I guess. Again, maybe using the way we use morphology is a bit ambiguous, because when we talk about the object model, that's really more than just the relative locations to each other, which is like what maybe you sometimes mean when you talk about its morphology. But then the point that you raised, Neil, said the object kind of has to have the correct shape to apply the behavior, is something that just naturally comes out of it. Like, we won't anchor the reference frame of that behavior to an object if those changes at those relative locations are not occurring, because the object doesn't exist at these locations. So for a behavior to be applied to an object, those changes, the object needs to exist at those locations, and the changes need to be happening at those relative locations. But it doesn't need to know anything about the object model itself, or it's not tied to that object model. You can still apply it even to these artificial setups, like even to the ball. You can make the hinge small enough to fit onto the ball, and then imagine parts of the ball moving.
Yeah, but only parts of the ball. You would not be able to map it on the new relative locations that are defining the ball. Like I wouldn't be able to move the upper hemisphere of the ball like up and down to mimic that behavior. It will still be tied to to the relative locations of the stapler.
Why?
Because just like you said, it's only going to move parts of the ball that adhere to these relative locations. Otherwise, it
But it
wouldn't be
has
able
nothing
to.
to do with the stapler. Like, this column doesn't even need to have a model of the stapler. It To recognize the hinge behavior, it's really just the changes at locations in a sequence of changes at locations. And these locations are in a reference frame that is unique to that behavior. So all of those locations are unique to that behavior, and it moves through that space in the sequence that it's learned for that behavior. So then it can apply that. Like, it doesn't know anything about the stapler at all. It might have learned that behavior on the stapler because it observed it on there first, but there's no connection right now between the two models.
It doesn't know it's a stapler, but it knows. I'm sorry. The relative locations is kind of what's confusing me, because I feel like we are building associative connections between the relative locations, which I know we're not storing any features there, but they are still defining how the stapler looks like. Because the movements are stored at these relative locations. If the relative locations are changing, for example, you change from a stapler to a laptop, the hinge is like it's becoming a different kind of hinge, but it's the same behavior.
I mean, they don't tell you how the stapler looks like. They tell you maybe where the stapler exists, but they have no information about how the surface of the stapler looks like, what curvature it has, where the polynomials are, what the color is. They don't store any information about how the stapler looks like. Only where it observes changes.
Yeah, but you want to observe
yeah, maybe
different places also on a different object, because a different object would have different places where you want to apply the same movements.
maybe to paraphrase, like I feel like this gets more into kind of the outstanding open questions, which is like if we apply a novel behavior or a behavior to a novel object, how do we predict the appearance of that object as it moves? And like we've kind of talked about potential solutions, like maybe it's something about kind of like anchoring point to point and things like that. But yeah, I don't think the current model necessarily like solves all of that. So I think it's something we
Yeah,
can
we
like
haven't
talk more
solved that.
about. But just I think it's useful to have that framing so that it's clear like, okay, what have we discussed and we at least think might be right, and what is more like open questions that we need to do that we can just brainstorm now and try and understand better.
Yeah, I think
So it sounds like your questions are more about kind of like this open question rather than
yeah.
because I think your description was really good and accurate of kind of the current model.
Okay, I just want to say I don't think I did a very good job in my write-up and explaining what I was actually aiming for. But this exact point is what I was actually aiming for. When I say apply a behavior on a different morphology, um, it's this open question. This is what I'm trying to solve. And maybe in my presentation I could do a better job of how to do that.
Yeah, I think that's a good
Yeah.
distinction to make because that's something we have not figured out yet. And yeah, thanks Niels for pointing that out. I
Yeah,
think
no
that's
worries.
that this proposal here is incomplete. It has some nice properties, and the one that I was focusing on is that the two models are really quite independent, but we haven't really we need to make them a bit more dependent, and we haven't quite figured out how to do that yet to actually predict. I've learned the hinge behavior on the stapler. I have this general hinge behavior model, but now how do I apply it to a different object and actually make predictions in the features about the features on that object? And that's an open question.
And this makes total sense. Yeah, just I think that in my presentation I will I'm not sure, but I think that I will try and define maybe a behavior space where they might not be aligned in physical 3D space. So it might deviate a little bit from what we have here, our understanding, but just maybe just take it as a proposal, not as a, this is what I'm thinking. Just maybe discuss it.
It might be, I feel like it might even be useful to almost like do a spectrum. So maybe like, I mean, if you find it helpful, but like maybe start with like the Pac-Man behavior on the clock or stapler on a laptop or something like where they are similar, and then go from there, because at least I think it's more intuitive if nothing else. Obviously, if what you're proposing can solve it in the more general case, that's great. But yeah, before kind of jumping straight into like the hardest ones, which is like, okay, can we even apply a stapler behavior to like a very different object like a sphere, or is that kind of learning a new behavior and things like that?
Okay.
Yeah, and just one more point to make, I guess, if you scroll down to the lower figure, the one that's much more complicated. So they are the two reference frames are only really aligned in their space when we learn the new object and behavior, because then we really just move through the two reference frames in synchrony with the same input, and we're laying down points and learning about it. But then when we recognize them, we can recognize them independently, and we can recognize them at different locations and orientations. So for example, if you look at the yellow arrows that go back down to the thalamus, the orientation in layer 6b might be a different one for the object model that we're recognizing than for the object behavior that we're recognizing. Like I might have recognized the hinge on the stapler, and then I recognize the hinge on the door, and it's like a totally different orientation.
Right.
And then we'll need to modify the movement that goes into the two different reference frames in a different way. So it's not like we always, and there might also be different scales too, like you might apply the hinge to a smaller part of another object. So
Yeah.
they're not always aligned. They're not always exactly the same if you're thinking of it in more physical terms.
Yeah, they wouldn't be exactly the same because they also anchor differently. One is anchored to a
Yeah.
behavior, the other is anchored to an object.
Exactly, yeah.
So, but the movement will move them in synchrony, but they'll be different representations.
Yeah, exactly.
Yeah, this makes sense. Okay.
Yeah, and then yeah, I guess on this diagram, one thing we can discuss is like, yeah, something that Viv and I were just discussing on the document a minute ago, which is whether L5 might also work as a location for the behavioral model, which I think we've also talked about at some point in the past, but just because L3 and L5 actually tend to have really strong reciprocal connections. Like some people almost think it's like two parallel pathways in the brain, L4 and L6 and L3 and L5. But then L5 and L6 have really strong reciprocal connections. So it kind of fits with, and
I
even
really
if
like
the
that
movement
idea.
in, cool, and yeah, like even if the movement information is coming in at the border between the two, that also kind of fits with both of them path integrating based on sensor movement. And then yeah, motor output getting
So is that
Yeah, I
5A,
really
5B?
that like if we talk about goal states and the goal states matching the behavioral
right.
states or using it to plan movements. And yeah, I think
Yeah,
even in the Mentas paper, they talk about the two parallel systems and the
right.
L5 reciprocal connections.
Yeah, so L5 and AB, I always forget. So I think so in primates and rodents, I'm just referring to the hierarchy paper. Yeah, they're reversed. So L5A are the large cell bodies. So that's intrinsically bursting. So in a primate. So those are the goal outputs. And then so I would imagine that it would be L5B in primates probably. Because it would be like L5B is like doing the behavioral state space, and then L5A is taking that information somehow and then proposing a goal state that gets sent out. But yeah, in case that helps with the
But then
presentation.
the change that's coming here, these are magnicellular projections.
Yeah.
Because from what I've been reading is that these are going to 4C alpha or 4C beta, something like that. So I'm not sure if so because if we're talking about blobs, also from what I've been reading, these are coming from conicellular, not from magnicellular, but I don't know if they do represent change. So
yeah, okay.
I mean, we could still have if we have both of them in 6A, they could still be making associative connections with 4C alpha and 4C beta, and just separated in sublayers.
Right.
But
Yeah, I think that'd be interesting to discuss the inputs. Was yeah, like we could I don't know if you have that paper or that was talking about the
let me just find it first.
one paper I thought would be interesting just to like quickly show is this Gilbert et al. From, or I think it's just Gilbert actually, from 1977. But it's a good example of where they looked at the kind of response properties across different layers of cortex and saw this pattern of these like really small receptive field movements in the kind of shallower layers, and then much larger kind of receptive fields for kind of detecting movement in the deeper layers. But this is kind of, if you hadn't seen this before, like when we're talking about that L6 is kind of integrating like movement from the sensor moving versus like the superficial layers are detecting like the movement of an object feature. This is the kind of stuff that comes from. But yeah, as with anything, it's, I guess, complicated in terms of which layers are actually doing what. Like here, it's kind of everything between L3 and 4C have kind of some degree of movement detection, it seems.
Mm. Let me share this. This was shared in one of the write-ups. Basically, the magnocellular would go to 4C alpha and parvocellular would go to 4C beta, which fits nicely. I mean, if we want to just have associated connections with layer 6A, because I don't know
Yeah.
6A if it just goes into one of these. Like I think it would just make associated connections with both. So maybe and then
Yeah,
the
right.
cellular would go into the interblobs in layer 2 3.
Yeah, I'm trying to see. Let me just need to get the latest copy of the Hierarchical paper. I don't know if you've struggled with this, Vivian, as well, but because the Hierarchy paper is under our personal email addresses, I always have to log out. No relief.
Oh, I think
Okay.
I can just invite you with your TBP one, or I don't know for
Okay,
me.
I wasn't sure. I think we've hit the maximum because and Subutai is also like the owner of that
Oh,
document.
yeah, I'm gonna move it to another document anyways to format it properly. After
Okay,
the
yeah, if it's
first
possible to
part.
then move it to
Yeah,
TBP stuff,
sure.
that would be amazing. Yeah, do you remember, Vivian, the kind of sources or whatever on magnocellular input? And I guess was that what you call it? Was that from the Cortex textbook, the one you were showing, Rami?
No, that was from a
in
paper that just talks about these
Okay.
parallels. So it was tracking them from the retina, from the ganglion cells, all the way to the striate cortex.
Yeah, okay.
these are the ones I have here right now. I don't know if you mean those, Niels.
Yeah.
Uh,
Or-
or what specifically?
Oh, actually, let me look at your giant PDF. Oh, it was just a question of movement,
Yeah,
where that's actually coming in.
my giant PDF has like several images from different papers that show different things. So I feel like it's kind of
Okay. Doesn't
mixed.
necessarily give clarity.
Yeah. I don't know. Here's one of those papers that I reference in the hierarchy paper. But I don't know, it just shows magnocellular to layer 4C alpha,
Yeah,
parvocellular
okay, so that's
to
consistent with
uh,
what you're saying, Rami.
Yeah, then they also go to the blobs. There is a lot of text about that. I think there's a lot of controversy of whether the magnocellular and parvocellular they stay separated and segregated even when they get into V2. And there's arguments for yes and no. So
Hmm.
What is a blob? Sorry, I'm not familiar with that term.
Yeah, it's
I think Niels had a nice figure for it.
Yeah, let me pull it back up. But basically, it's
this one.
it tends to be cells that are sensitive. Oh, color.
Stop sharing.
Yeah, there's a few different ones visible there. Sure. Yeah, cells that are particularly sensitive to color are kind of detected here, and I think under certain stains they kind of form these like blob-like structures, which is what their name comes from. But they're kind of, in general, like when we talk about kind of mini columns and stuff like that, Jeff's often pointed out that, so that's like, where you see like, so that's kind of indicated here with like the orientation. So like all the cells in L4 at least kind of tend to respond to like the same orientation. But maybe that kind of mini column structure is kind of going throughout all the layers to a certain degree. Like maybe they're detecting all motion in a certain direction as well and things like that. So this kind of fits with like, okay, these are all cells that are sensitive to a particular color. But it's interesting that they're kind of conspicuous, that they're almost everywhere except for L4. So even though they're kind of representing features, something like color, they're actually kind of outside of the classic like feature detection layer, which fits maybe with kind of, I guess, where our thinking has been evolving, which is that like L4 is more representing orientation, and then it might just be kind of these might just be neurons that kind of respond weakly to color and then kind of bias this column when color information is there, like more likely to see a banana if it's also yellow, and things like that. Which, yeah.
So from the coniocellular goes into these blobs, and they represent blue-yellow opponency from the retinal ganglion cells. So they might do some color, but I'm not sure.
If you go 2 pictures to the right, I think it shows that what Rami just said. It's an interesting one.
This one?
There, the blob actually extends to layer 4A, but yeah, the concellular cells projecting to the blob, and magnocellular to 4CB or A.
Yeah. Yeah, right.
Yeah, they show interblobs as like a blob-shaped thing too. I thought it was just the space between the blobs.
Yeah, there's another distinction in V2, which I don't know what to make of. I don't feel like I fully understand it, but these layers, the thin, thick, and pale layers, and projections from different parts of V1, they go to different layers in V2, which this is the next version of blobs, I think, in the V2, but don't understand them very well.
What book is this from? This figure? Is this from a paper?
Yes. I don't remember which paper, but I've seen it in multiple ones. I could send you some references. Yeah.
I'm just wondering if it was the book on color vision, or
No, maybe I don't know. I'm not sure. I can look it up and. I think I was trying to make the argument that these pathways, they stay segregated even into V2.
But yeah, Vivian, that might be something worth us querying with Jeff in case we want to update those figures, because
The layer
in general,
5.
it's Well, just how we kind of represent the movement information coming in, because often it's shown at that border, but between L3 and L4. But we'd obviously want like an actual citation for that.
Yeah. Here's the other one that I referenced there, where we have, this is an interesting picture, I guess, with the retinal ganglion cells going to the magnocellular and paracellular ones in LGN, and then again here it seems like layer 4B.
Yeah,
Even though they show
that's nice
magnocellular
figure.
going for C, but then they show movement being extracted from that somehow here.
It's still in 4B, so
Yeah,
that
the input
doesn't
would be
that
for
doesn't-
C, but yeah.
Yeah, the the dividing lines in the figure don't correspond that clearly to the labels on the right hand side. It's
Oh,
like
yeah,
it's like 4A is written on like the border between one color and another color. So it's like, what does that mean? What is 4A in this figure?
yeah,
But maybe that's the point, is that there's like functional divisions and then there's like anatomical ones. Um, maybe they're focusing on the functional ones.
yeah. This one is just about functional segregation.
the movement projection that goes into 4C alpha or whatever. This is different from the behavior ID that gets pulled into some like a more superficial layer, right? So we would still want the behavior ID to be in layer 2, 3, layers 2, 3.
Yeah, and this actually helps because one of the other issues I was worried is kind of like, are we expecting kind of too much of L3? Because it's like, is it going to do behavior ID, object ID, and motion detection and all this kind of stuff? And if it's doing motion detection, it's not that clear why it's then passing that information on to the next cortical column in the hierarchy. I mean, I think
Yeah,
we once thought like maybe that was like a form of skip connection or something, but yeah.
I think we said we can't have the behavior model in layer 4 because the like time matrix cell projections don't reach to layer 4. But like only the neurons in layer 3
Oh,
signals
have the
onto that.
apical.
Yeah.
Interesting.
Because yeah, I also like suggested maybe the behavior model is in layer 4, but at least that was the argument against it.
So I guess the high level behavior model could still be an L3, but the like if that's the kind of pooled representation, but I don't know if that necessarily is what needs the L1, the matrix cell input.
Does these apical dendrites, do they synapse on 6A as well, or just 5, or the ones that come from the matrix, the L1?
Right.
I don't think 6A.
Yeah, I think
5A.
L3 and IL5 are the ones that classically send apical dendrites, and L2, but 6 and 4 less so.
Yeah, that's my understanding at least.
Yeah, the reason I'm asking is because of the reference frame is associatively attached to or tied to the changes, then maybe there's a way to get this indirect signal of overlaps through the reference frame.
Yeah, I think it would have to get it through the associative connections.
Okay, yeah, so I guess that's some some more neuroscience questions to think about and maybe look into.
Yeah.
But yeah, but it does feel like maybe we're kind of narrowing the space where these things could exist. And yeah,
Yeah, I think it would be worth going a bit more into depth back into the literature on like what we know about the anatomy and connectivity of especially layer 2, 3. I mean, yeah, it's kind of a shame that people just look at them combined in a lot of cases.
right.
But yeah, that would be interesting or useful to figure these questions out.
Really, maybe go through the open questions one by one, read through them, and see where we're stuck.
Yeah, that's a good idea.
Yeah, sounds good.
Just to kind of get a high level overview of all the things we need to figure out, and then we can go away and take a long walk and figure them out. Yeah, should I briefly go over them? I mean, yeah, I guess just intersect if you have thoughts on any of them, but we can also just collect them. So yeah, can we learn associative connections between the reference frames was mostly a question. It's a bit of a smaller question, but it might give us some insights into how they inform each other and how we can apply the behavior onto a morphology. But mostly I was just thinking about if I recognize an object's model, I also know, like, and I've learned its behavior, I should be able to predict its behavior model already. Like, I don't have to infer the behavior again. Like, there seems to be an association that we could learn. Like, I see the stapler, it's not moving, but I know what behavior it can have because I've been moving before.
But we also that the behavior could the behavior also inform the object? I know you said not sure that the other way would make sense, but why wouldn't it?
Yeah, I guess I couldn't think of a good example where you see the behavior, but I guess it could. I mean, maybe if you see like a shadow of something moving, it gives you some idea of what object it might be.
Yeah, I think it makes sense that it could at least bias the recognition of an object.
Yeah.
Um,
And I guess this would really be more an association between the IDs of like the behavior ID and object ID. That's how I was thinking of it. Like if you recognize the behavior ID, it increases the likelihood of a certain object or the other way around. So yeah, I mean, I don't see any reason why we can learn it the other way around, I guess.
I think the video that Will was sharing during the retreat with the motion capture points walking, that would be maybe some behavior
Right.
informing the person.
Yeah, that's a good example. This one, I don't know, Niels, I feel like this deserves to be its own point. And yeah, if Jeff joins it in 10 minutes, if he just didn't get the invite updated, maybe we can ask him about this.
yeah,
What he would think. And then
yeah, and maybe revisit also. I'll look at. I don't know if there's anything on the different sublayers of L4 and what if some of them have more connectivity to L6 versus L5.
Yeah.
If anyone, if there's any literature on that.
Yeah. So yeah, let me quickly go over the other ones. This one is more of a smaller one, just like can multiple behaviors be detected at the same time? Guess it's more of a side question. I didn't bold that one. Then the big one is like, are there compositional object behaviors? Like we have compositional objects. So basically for compositional objects, we have this very concrete idea that we have in the hierarchy paper of, all right, the object ID gets sent to layer 4 of the higher level and becomes a feature on that model. And we have these backward projections and we calculate the relative orientation of the child object to the parent object and send that up here. But is there an analog to that for the behavior model? Or do we not actually learn behavior models in a compositional way, but instead just recognize higher level behaviors here? Yeah, that was kind of the question we talked about at the end of last week's research meeting.
Yeah, maybe I feel for that one. I don't know if it's useful to define what we mean by hierarchical or compositional behavior. Like to me, the one that's open is like a behavior where the child's behavior directly impacts like the parent or vice versa, as opposed to where the
Yeah, what
behavior
I
is kind of
mean,
self-contained.
yeah, so what I mean by it is where the behavior ID becomes a feature on a higher level behavior, instead of like, definitely you can learn behaviors in this higher level as well. Like that's why this purple part is here.
Sure.
Like you can learn a behavior model here for sure. But does this
And when
behavior
you have
model,
behavior IDs as features coming in, I feel like there's lots of cases where that would be the case.
in most cases,
Like yeah, for example, like something like a car door or like a car or something like, you know, you have something that's a low level as like the handle on the door and then opening the door itself, and then you have turning on the car, you have moving it, like these are all kind of like interrelated, probably in some like higher compositional object, and that higher compositional object can have behaviors like driving and stuff.
yeah. I mean, you could argue that those are all behaviors applied at different locations on the car. But yeah, definitely see the point that it might be necessary to learn like causality between different behaviors or how they are
Yeah, because
connected to
otherwise
each
it
other.
gets really complicated. It's kind of like trying to model like an entire object with one reference frame. Like we kind of want to
Yeah.
split up. And I don't see like a fatal issue or anything like problem with having nested behaviors.
Yeah, then I guess the second question would be, like, would the behavior ID actually become a feature on the object model here because it's a static thing, or on the behavior model? Because like how we defined this so far is that the behavior model encodes changes, so it would, by that definition, only encode if the object ID or the behavior ID changes from one step to another. And then when it stays static, it would be actually part of the object model, which is confusing to think about.
Right. Yeah, no, that's interesting.
Yeah, then we had this question about like applying these temporary masks, like when we have like that was kind of an attempt at solving the problem of how to make predictions about the objects, like how to apply the object behavior to a new object morphology, basically kind of masking half of the stapler and just rotating that part of the stapler, for example. Yeah, I guess this is a very open question. And then I guess I should probably move that down because the next one is pretty related to the previous one. So whether object behavior ID is treated the same way as object ID in the lateral and backward connections, and also how we communicate timing in the behavior. Like, do we only communicate the behavior ID, or do we communicate behavior ID plus where we are in the sequence of the behavior?
Yeah. Yeah,
Like
maybe,
almost,
yeah, we can write sequence sequence location or something like that.
yeah,
Sequence point, just to clarify the difference between like seconds and
yeah.
sequence. uh Sequence. Can we vote on just sequence position? Something like that.
Sure, yeah.
Position. That sounds less weird.
Yeah, that sounds good. Yeah, and then these two, yeah, no, these are better ordered. This one is related again to the temporary mask, the more general question of like how do we predict morphology in the middle of a behavior? Like what we talked about earlier, like a big unsolved question. Also, what if the
And
behavior?
yeah, and I think arguably it's still unclear even in the case of an object we have learned it for. Like even with
Yeah,
the stapler, it's not, and we even if we learn the hinge behavior with the stapler, it's not obvious how we predict what the stapler is going to look like at a particular
right.
location, let alone applying hinge to a new object.
Yeah. So we basically, our proposal currently allows us to recognize behaviors and objects independent of each other, but it doesn't allow us
Right,
to make predictions.
right. Yeah.
Okay, then I guess a bit related to the temporary mask was this idea that maybe object behaviors can also help us segment objects into subcomponents. Like if we see a part of an object move, that tells us kind of that that might be like a child object.
Which again, I think fits well with like compositional behaviors because it's kind of like the more complex a behavior is, the more likely we are to segment it into like, or the more complex how an object changes is, the more likely we are to segment it into like child objects with their own behaviors. So like, I think Jeff often gives the example of like a transformer model or something like that. But like, if it's this thing that does like loads of stuff, you may kind of understand each of those components and then how they fit into the whole thing.
Yeah, I mean, to me, I would almost think of it as like, I don't think the segmentation part would necessarily require a compositional behavior model, but it requires hierarchy for sure, since we have child and parent objects. And basically, how I would think of it here is we would recognize the behavior in the higher level column, like I think we had this weird example of the chair where something hinges off in the back, or
Yeah.
I don't know where this example came from. But we see a move, we recognize the behavior here, and then that would somehow inform down here to split up the object into subcomponents that then become parts of a compositional object here. Like the object that we are decomposing is the object model, not the behavior model, right?
Well, maybe, but or both. Like, I don't know, say it's a rocking chair and then it has like a little button on it that does something, lifts up or I feel like the rocking chair is the behavior of the parent object. The rocking is the behavior of the parent object. But then we may kind of separate out this like, oh, on this location of the object, there's this other smaller object that has its own behavior, which is to like flip up and then you can press a button on it or whatever.
Yeah. So then that flip out button would be the behavior recognized down here, and the
Down
rocking
there, yeah.
recognized up here.
And then to your point
And the
about
rock
like,
here.
yeah, like is it the change that's passed, is it the behavioral ID or the change of behavioral ID that's passed up? It's almost like it almost seems to fit in with like if the behavior influences the higher level, it's because there's a change happening that's somehow interesting. So it's like if they're totally independent, like I don't know, the button flips up and you can press it and it turns red or something. That's just like a feature at a location that can be different at different times. But if it's like pressing the button causes the chair to start spinning or something, then it's almost like when you get that, sorry, it's such a crazy example, but then that change, the fact that the behavioral state is actually changing is almost like informing the high level behavior. I don't know, something, yeah.
Yeah.
Thinking of like a keyboard that has maybe like two behaviors, like you can type in QWERTY or you can type in Dvorak or Colmac or something like that. And then there's a light on that keyboard. If it's blinking, then the behavior of the keyboard is this type of like QWERTY or Dvorak. If the light is, if it's green or if it's red or whatever, it changes the behavior of the whole keyboard. I don't know if this would be just like a causal thing or a compositional behavior, because the change of the light from red to green is a type of behavior for the light. And then the state of whether you're typing in Dvorak or Colmac, that's a behavior of the keyboard.
Yeah.
Yeah, that kind of I mean, yeah, I don't want to sidetrack what you just said too much, but it reminds me again of this big open question of how do we predict morphology based on behavior. It almost seems like where we are in the behavioral sequence needs to give us like a state kind of thing, like whether the light is on now or off tells us what the morphology model should expect. Like, yeah, I'm not phrasing it very well. I guess in your case, I don't know if the letters actually change when the light switch. They change,
Yeah,
or
when
just when you type them, you see something else.
the order, the whole layout changes. So the layer, so the position of the whole behavior of the keyboard changes, but but yeah, it's just the layout of the keys. So it'll be completely different, and
Yeah.
you just adjust to it. And so you know if the light is on, I know that the way I'm going to use this keyboard is completely different. I'm going to type in a completely different layout, or you can just change languages. You're typing in a different language.
Yeah. Yeah, that
Yeah,
seems
one
like a version of predicting different features based on which stage in the behavioral sequence we're in.
yeah, in terms of the like hierarchy and predicting object morphology and stuff, like maybe we don't want to go down this route, but like, if you let's say represent a stapler as a compositional object with the upper arm and the bottom arm, and the totality of the behavior of the upper arm is that it can rotate and move through space, but it cannot like deform within that object, then in some sense that makes it easier because it's like the relative positions of objects does not change. It's just like the whole thing can move through space and reorient in space. And then that's like that's a state that gets passed up to a higher level region, which then might model the kind of actual the motion of that relative to the bottom one. And then yeah, I don't know, something, and then like if you have the child object, that can tell you what, given an orientation of that stapler arm, like you can see where
Yeah.
if that makes sense. But yeah, it also feels like it would be constraining because yeah, we don't want to have to break everything up into children and parents. And if we have a really complex object like I don't know, a balloon that you can kind of squeeze in any dimension, and then it's how do you model that?
Yeah.
So what you're saying
Yeah,
is that if
definitely a big yeah, go ahead.
a high level behavior can be decomposed into just a change of orientation if we just keep going all the layers down.
Yeah, kind of. So that like maybe yeah. But
if we can
then
do the
I'm not
math.
sure actually that kind of works, because in the stapler object, there still has to be some sort of change. Like there has to be some change that's more than just the orientation and the position of the whole object. So
Yeah.
I'm not sure it helps that much. But I mean, I think it hints at like, it still feels like the solution to this, like predicting what morphology has something to do with like associating locations between models. And it's like the more complex the behavior, the more you have to learn these associations to be able to predict what feature you would see. But if it's like a simple behavior, you can fairly easily map on what you would expect to see after the behavior has happened in terms of the features at locations.
Yeah.
But yeah.
Yeah, definitely a big topic to think more about.
Yeah.
So yeah, I guess I'll move on to the next question for now, just so we can go through them all. So yeah, this one is so basically movement within that behavior reference frame is path integratable. Like you can observe a behavior at different locations, and it doesn't matter in which order you go through them. And this is like a reference frame, like we have the reference frame for the object. But we also have this sequence of states, basically, or like sequence of changes. So the question is whether that is somehow path integratable, or it's really just a sequence and you'll have to learn different sequences for more complex things like a joystick. Like for example, the behavior of a joystick, do you have to learn a bunch of different sequences of how you can move that joystick back and forth, or can you learn like a more general space of how you can move through that like state space of the joystick?
Yeah, and maybe those aren't mutually exclusive, in the sense that like if you can represent something as a composition of small sequences, that is basically a path integratable space. As in like if you've learned an edge that like, oh, if I move the joystick up, it's going to be like this. That was a sequence at the time you learned it, just that simple transition. But if you're able to chain that together with another one and another one, you can probably do path integration. Like what we want to avoid though is like you have to learn like, oh, I do right 2 times, up 5 times, left 2 times, blah blah blah. That's one sequence, and then that's separately represented from a totally different sequence.
Yeah,
But yeah, so
yeah,
they
that's
may not be as separate as.
yeah. I like that's a that's a good point that these sequences you might be able to combine them to become a path integratable space. Awesome.
All right.
Hey, Jeff.
Hi there. I'm so sorry. I got told into something this morning at the last second, and I forgot to tell everyone I was late. Anyway, sorry to
No
join you
worries.
so late. Sorry to join you so late. I can't tell if you guys can see me or not.
Yeah, we can see you.
All right, I'm just standing outside on my phone. Keep on.
Yeah, no worries. Yeah, we just had a kind of high level discussion, I guess, of some kind of neuroscience and different things, and then now we're just kind of going through the existing open questions,
Okay.
and doing a bit of discussion, but with the idea that it's just kind of revisiting them so we can think more about them.
All right. Well, just keep going on, and I'll join in.
Okay.
But yeah, actually, we went through the main questions around object behavior models. The remaining ones are a bit more longer term questions around like actions and goals, and a bit more about the mini-column representations and anatomy. But I think now that you're here, it might be worth revisiting a couple of the topics we
Oh, I'm
talked about.
sorry.
No worries. But Niels had a pretty interesting proposal, so maybe Niels, if you want to.
Is that the
Um,
the layer 5 behavior thing?
Yeah.
Yeah. I wrote while I was not on the call doing something else. I actually wrote a response to that.
Oh, okay.
So
Okay, cool.
I wrote a lengthy response to it because I was thinking about it. I just had to meet this contractor person anyway. So I apologize. Yeah, so I thought it was a really interesting idea, and you'll see that I posted a lengthy response to it. Yeah, there's a lot to like about it. So
Yeah, and I think we've often talked about, in like going back, that L5 would be where behavior would be represented because of
right,
the motor out projections and stuff. But
yeah,
I don't know if maybe just over the hackathon, because we were so focused on the space being path integratable, that it kind of
well,
naturally
what it would
we talked
mean,
about L6. But anyways,
what it would mean is that, in my mind, for the two reference frames, the morphology reference frame and the behavior reference frame, they would likely or almost certainly share mini column definitions, in the sense that I'm continuing to work on the idea that mini columns are the basis of grid cells, and that the cells in the mini column all representing movement in a similar direction. And so you would want both the behavior reference frame and the morphology reference frame to be updated simultaneously by the same movement vectors. And so in some sense, if we say layer 5B is the mini columns there, or the reference frames for the morphology model, the behavior model, and layer 6A are the mini columns, are the reference frames for the morphology model and the behavior model. I said that wrong, I'm sorry. That they would share, you would see the same. And so what basically the difference is, both those layer 5B and layer 6A would be updated simultaneously, but they just anchor separately. Right. So you can imagine the input to the column goes between layer 5. They always say between layer 5 and layer 6. So you can imagine it goes in there, and then it projects upward and downward at the same time, because it defines the same mini columns, but they just get anchored separately. And then layer 5B also, we know, has long range connections, so that would be voting on behaviors. So that all makes a lot of sense.
Wouldn't it technically still be different movement vectors for the two? If, for example, the behavior model is recognized in a different orientation than the object model, they are transformed in different ways in the thalamus, since it's in the object's reference frame at this point?
I guess that's a possibility we discussed. I don't know if we know that there's enough down projections for that, or like from.
It would have
it'd
to
be nice if it has that flexibility.
Interesting. Interesting.
In some ways, it kind of fits with the alignment of the behavior with the morphology, that like you can't apply, or you probably can't apply, like a behavior to an arbitrary morphology if there's no way that they align. In some ways, the orientation also has to be aligned in order for them to match.
Well, does it?
Still,
well, as in, like, the hinge has to be aligned with.
I could have a hinge that's vertical on an object and a hinge that's horizontal on an object. In one case.
But so in that case, aren't both the morphology that is doing the hinge behavior and the behavior itself oriented together?
But you might have learned the stapler model and the hinge behavior on the stapler model in this orientation, but then you see a hinge, like a door, in this orientation. You're not recognizing the stapler, you're recognizing the door.
I guess what I'm saying is the morphology of the hinge on the door is also oriented. Like, if it was a stapler, it would be oriented the same way as the behavior. It would be rotated.
I'm missing that. You might be right, but I'm missing it. It seems to me like, let's say I have a light switch, an classic old light switch, a little thing you flip up and down, right? Well, now I mount that on another object where it's horizontal. Okay, so
both the morphology and the behavior are rotated in that case, right?
No, but the object that it's on is I have two objects it's on. I have a little, I don't know, some toy, whatever, and one toy has a switch horizontally and one toy has a switch vertically. Wouldn't they require two different? I mean, so the behavior to turn on the switch would be different. It would be. I mean, you might be right, Neil. I'm just. It's not obvious.
Yeah, I guess in that case it feels like it's like a child object or whatever. Like the switch, if that's represented as like an object, then that can be oriented in different ways in space.
Well, that's true if it's a child object, but we can't say all behaviors are on child objects because they have to exist in every column. So
yeah,
well,
I mean, I thought the nice thing about this proposal is you can recognize behaviors on a bunch of different locations, and a bunch of different orientation and different scales on different objects. So it seems like that would require
here's an idea.
Behavior model to send separate hypotheses down to the thalamus to rotate into its reference frame.
Here's an idea. Well, let's assume what if there were two separate orientations? And what strikes me there is that one of the funny things about the thalamus is it seems like these layers in the thalamus come in pairs. You know, this is a really half-baked idea, right? So don't hold me to it.
Well, I think that's also what Vivian. That's what you kind of been suggesting, right? That there was two different movements.
Yeah, exactly.
Yeah, right.
So this is what I drew here, that the two have two different orientations that are recognized, and they are projected to the thalamus, and they separately rotate the incoming movement that goes into.
I haven't seen this figure. This is a new one.
Yeah, it's the complex version of the
but you cleaned it up. So maybe I did see this. I can't. I don't remember there being two different orientations.
Yeah, that was only in the complex version of it.
Okay. Yeah.
Oh no, it's actually the two different orientations actually in this one as well. That
Really?
those two are supposed to be different here.
Well, but there's nothing indicating it's different there, right? Is there?
Oh,
I see. Oh, the little. I didn't really pay attention to those. Well, I mean, but this more than that. It basically, that says it, but it doesn't say what the mechanism is. I guess I didn't follow through on it. I mean, this would basically be saying it's sort of like two separate columns. You know, if I had two hierarchically arranged columns, they have different orientations, and you know, a child orientation versus the parent orientation. And in this case, we're saying that the behavioral model and the morphology model might have two different orientations, and then you'd have to have two sort of projections back to the thalamus, and the thalamus would have to do two different transformations. Unless Niels is right, and I don't understand this guy. I understand his point. But...
No, I mean I'm down for that. I was just thinking, whether it's necessary, but
well, it seems like it is, but I could be wrong. I mean, it's an extra complexity. We don't really love to have complexity, but it seems to be.
But I feel like that maybe simplifies the idea of having one of them in layer 5B. That we don't have to assume that they get exactly the same movement.
Okay, how are you?
Well, I think they have to be updated the same, don't they?
Yeah, I mean the movement that goes into the thalamus is the same, but then it gets rotated into their respective reference frames.
Oh, I see. Right. So
And
so
for what it's worth, these could be separated out in time if needs be. Like, I don't know, even if there's
Well, nothing is they can not only get they have different orientations, they can have different scales. Right. So it's an issue we've never really dealt with, but has to be dealt with something. So that would, I think, Vivian, you're arguing, and maybe convincingly so, that that these things really aren't tied together, like I suggested. That they have to be driven from the same basic movement vector, as you say, going into the thalamus. But after that, they have to get translated separately. Movement in the behavior frame versus movement in the morphology frame, different orientations and different scales. Anyway, then I said to myself, well, how's the thalamus going to do both of those things? And then I said, oh, look, the thalamus comes in these layers, and there seems to be two of every type. so maybe that explains. I always wondered, why would there be two layers of every type? You know, what's the point of that? You know, and even the ones that are left and right eye, I believe there's two left eyes and two right eyes. You know, so anyway, that could explain why you have multiple layers in the thalamus.
Yeah, and actually the scale example, I think you've convinced me, because that one we definitely need to change it. So
Right.
no, I think that
But
makes sense.
This requires a bunch of other stuff too. I mean that the projections to the thalamus have to come from different places. There has to be two orientation projections to the thalamus. One goes to one layer, one goes to the other layer. That's not out of the question. It's just not something I know about, but maybe someone has observed that. Yeah.
And then I guess on this kind of revisiting the microcircuit, Rami brought up the interesting point that if you actually look at a lot of the literature on the magnocellular input and the movement input, it tends to be there's like L4C, at least in V1, this kind of lower part of L4, whereas we've often kind of shown it coming in as the border between L3 and L4. I was just wondering,
Well,
do you remember, was that kind of an indirect? Because like, yeah, if you
No,
look at the responsiveness of cells in
remember,
superficial layers,
striate V1 is unique to primates.
yeah,
And I have zero theory about what those extra layer 4 cells are doing.
yeah,
So when you look at the thing, it comes in, well, first of all, there's 3 projections that come, they're typically not broken out as magnocellular, parvocellular. Maybe people know that. I don't know that, but there's the one that's like, they typically see lower layer 3, layer 4, in the border between layer 5 and layer 6. That's what they say. Who knows? But that is typically, I imagine, would be non-primates and not vision, right? That could be whiskers. That could be rat being cat vision. So when it comes to the striate layer 4, I have no idea what's going on. I've never heard a cohesive theory at all about what the hell is happening. And I haven't thought about it myself. So I don't know if that impacts what you just said, but I just try to avoid that.
yeah.
What the hell's going on there? No one knows. Yeah.
Okay, yeah.
And by the way, some people have argued that the labeling of those striate layer 4 is incorrect. That they say, oh, people say there's multiple layer 4s. That's not right. Some of them should be considered, not layer 4. They're more like, layer 3 or something. I don't know, multiple layer 3s. So I heard that one argument made once.
Okay.
So
Yeah,
knows?
actually, I was just looking. I think there's this figure from Thompson et al. This was Alex Thompson. This is that like L6 huge paper.
Right.
So I don't know if maybe this was partly where some of this comes from.
So look,
because this seems to suggest
first of all,
more connections. Yeah.
Well, the magnocellular should drive in my mind, it should drive lower and upper.
Yeah. But with different receptive field sizes.
Well, right. It's driving the overall movement of the sensor in layer 6, and it's driving and it's detecting the movement of the object in layer 3. Of course, these don't show that. Again, this is the striate layer 4, so all bets are off now as to what these really are. It's hard to say. I wish,
But I mean, it's interesting because this even seems to suggest that you get the parvocellular input into.
Yeah, it does say that.
L6 as well.
It could be.
Like it seems they kind of, there's almost overlap in where they all project, except for this slight breaking down. Okay, that's something to maybe look more into.
There's so much stuff here. It just sometimes it's mind-boggling. Right. I don't know what to make of that. And sometimes you have to look at the real details. Like, are they following axons? Could these be projecting to inhibitory cells? Or they be, there's just a ton of stuff that's unknown. And there's multiple cell populations in each layer. And so which are they projecting to the same cells? It's crazy. I put in my little note, like, I always feel more comfortable when we deduce the function must exist than when we propose where it exists. The where it exists is like, it's half, it's guesswork based on guesswork. And you hope it's right, but but sometimes you find that the data you're working on is all screwy and it's hard to know. But you know, we can deduce logically that certain functions have to happen, and therefore there must be a cell population that does it. I mean, it's kind of a hand-waving excuse for not understanding something. So, it was interesting that Thompson image too. She didn't make any distinction between the two layers in the thalamus. You only saw the projections coming from one.
Right.
That was an interesting idea that might come out of this. There might be somebody who's got some evidence that there's differences between those two layers, that they're not just equivalent, duplicated, which is typically not, you know, you don't typically see things like that in nature, just duplicate something. You know, while we're on open questions, I put it in my little, well, I would like to remind everyone that, you know, we think at layer 6A is the reference frame for morphology. But we have no explanation for why layer 6A projects back to the thalamus. If I don't remember one. And that's a major projection. You know, why does the thalamus need to know where we are in an object? that's a.
I mean, it's interesting. Yeah, because here, the projections, I mean, doesn't this kind of fit with like, okay, this back projection is the orientation of the object. This back projection is the orientation of the behavior.
Well, that could be.
And both are.
Well, that's a good.
So they're separately applied to the magnocellular and parvocellular.
But what they say is the same cell in layer 6A will bifurcate like it's shown here, and it'll send a projection to layer 4. And again, this is the screwy striate cortex. I'm not going to pay too much attention to all the details, but the general rule is the layer 6A cell will project to layer 4, and it also projects to the thalamus in the same cell. So if it's orientation, that's great, but we're using that as the location signal for the morphology model.
But isn't it just kind of isn't it just a look? Like it is just a location. It's just like an association almost. Like,
well, but what if I'm saying I can see sending the orientation to the thalamus. I don't know why I would send the location to the thalamus. I mean,
could it be something to do with scale? Maybe that the grid cells are somehow detecting scale and
right. I thought about that because what it is. I mean, it's a very unique representation, right? It's basically representing a unique point on a unique object. So there in the world, there's a gazillion of these things, and it's kind of a high burden to expect the thalamus to be able to recognize them, right? It's like an SDR, which are many variations in the world, and so if that's correct, it's hard to imagine that the thalamus, which is a pretty small object, is going to be able to learn to recognize, do something unique for every location. But on the other hand, as you just point out, the scale is one of those things you might vary on location. Location by location, just like orientation is something you vary by location, you know, location by location. So, maybe that's the answer right there.
Yeah, I think it's something we've talked about before.
I'm just thinking. I just thought, did we? I should.
But I think your concern at the time was that, yeah, like the SDR. Kind of being too complex or something like that.
It's just too much to ask. I mean, I can't remember. I can't expect the thalamus to remember, you know, every location and every object and do something about it. It's just just not possible. But you know, it could be. You know, the idea that I'm confused right now. But the idea that there are some locations which are important to know. Where you might have a different scale, or you might have a different scale or a different orientation. You have to note at this location we have to remember this, but it can't be every location because it seems like there's just too much to ask the thalamus to learn. I mean, there aren't that many cells in the thalamus compared to the cortex, so you know. Anyway, I haven't been too worried about it. I just threw it in there, so just as we're talking about things we don't understand.
Would it be helpful in voting between sensors, like the two hands, the idea you proposed before?
but we're talking about the projection to the thalamus, right?
Yeah.
So I don't know how that would help.
One
in
sensor
both.
would need to know where the other sensor is to be able to.
Oh,
both.
that thing. Yeah, right. But I have trouble imagining that's happening in the thalamus. That to me would be, it could, that has to occur someplace, but I have trouble imagining it being the thalamus. It's not, it's like, that's a big open question, Rami. So, as to how it is that we know the relative locations of objects in Vodon. Anyway.
Yeah,
are we
just
listening?
we're kind of at time, so so maybe that's a good
yeah,
a good stopping
so
point.
we've
had lots of good questions to think about.
I posted some text on that document just a little while ago, and now that I've had this conversation, I'd like to retract some of the idea that I argued that the two mini columns in layer 6, the two morphology and the behavioral model should be the same, and Vivian convinced me that's not true. So I should retract that. Okay. Anyway, so okay, if we're done, we're done.